How's it going, everybody? Biles here. How y'all doing? All right. So today, what we're going to do is I'm going to do a couple examples from the power rule from yesterday, just a little refresher, and then we're going to do some of the examples from the stuff last night on the homework that y'all didn't know how to do, like writing the equation of the tangent line, do a couple of trig problems, and that'll be it. Your homework is going to be a Go formative once again. It'll be due tomorrow morning because you should know how to do all the problems on there now. Tomorrow and Thursday we'll do product rule and quotient rule. We'll quiz review Friday and we'll quiz on Monday. See y'all tomorrow. All right, so to find the derivative of this one right here, we're going to apply the power rule. So it's going to be f prime of x is the exponent goes out front to be 1/4 x. You subtract 1, which would be 4/4. So therefore you end up with negative 3/4 minus exponent goes out front, 7/5 x, subtract 1, which is 5/5, and you get 2/5. And because we are of Kooth and distinction, we would not have a negative exponent in there. This negative exponent is only going to affect the variable. So therefore, that's going to move it to the other side of the fraction bar. So you end up with 1/4x to the 3/4 minus 7/5 x to the 2/5. You can either put that in the numerator or just to the side like that. Either or is fine. All right. Now in this one, we have them all in radical form, so therefore we're going to rewrite them in rational exponent form, so that way we can perform the mechanics needed to find the derivative. So the square root of x is the same as x to the 1/2. The cube root of x to the 5th is going to be x to the 5/3. The exponent goes to the top, the root goes to the denominator of the rational exponent. Now we can perform the power rule, and you end up with 1/2 x, subtract 1 to get negative 1/2, minus 5/3 x, subtract 1 to get 2/3. That negative exponent needs to move that variable to the denominator. Don't do anything with this one over here. And so that is our derivative. Alrighty, good deal. And lastly, this one right here. I'm going to do this in a couple steps. This is the same as saying negative 1/2 x to the since it's the square root of x cubed, it's going to be x to the 3/2. And in order to perform the derivative correctly, I need to move that to the other side out of the denominator. So we end up with x to the negative 3/2. All right. Now I take the derivative. Negative 3/2 times 1/2 is going to be 3/4. X, subtract 1, which is 2/2. And you end up with negative 5/2. So that moves it to the denominator. So we end up with 3/4x to the 5/2. All right, so that's just a little refresher from yesterday. Okay, now in this one right here, we're going to write these f prime of a, f prime of b, f prime of c in order from least to greatest. These are the derivatives, which means the slope of the function at a, at b, and at c. Now a tangent line is going to represent the slope of the function at those points. And if we have a positive slope tangent line, it's going to look like this. It's going to be increasing from left to right. Negative slope tangent line is going to be decreasing from left to right. And a tangent line with a 0 slope is going to be a horizontal line. So I'm going to sketch the tangent lines at each of these points. Here's A. It's going to look basically like this. Here's at B. It's the vertex of a parabola opening downward. Hence, it's going to have a horizontal tangent line. And here's the tangent line representing the slope of the function at C. The smallest one is going to be the negative one, which would be f prime of c. Next would be 0. So it would be f prime of b. And the largest one is going to be the positive slope, so f prime of a. So that is in order from least to greatest. The smallest one is the smallest value is negative one, then 0, then positive. Okay. All right, now we're going to write the equation of the tangent line at x equals 1 in point slope. The equation of point slope is going to be y minus y1 equals m times x minus x1. All right, so we need to have the x and y value for the point that it goes through and the slope in order to come with the equation for the tangent line. So we have our x value of our point that it goes through. We need our y value. So what we do is simply take x equals 1 and substitute it into our original function. That gives us our y value. Okay, so I substitute in 1 in for x into the original function. 1 cubed plus 1 is 2. So the point that it goes through is 1, 2. That's our x sub 1, and that's our y sub 1. Now we need the slope. What gives us our slope? The derivative. So we're going to take the derivative of f of x, and we get 3x squared. To find the slope for our particular equation, we need to substitute in our x value, x equals 1, into the derivative. That's going to give us the slope of the function at that particular point. So f prime of 1 is going to be 3 times 1 squared, which is 3. And so therefore, so if we plug these in, y minus y1, which is 2, equals 3 times x minus x1, and you're good to go. That is your equation line in point slope form. Skip that one. Okay, we're going to find the points on the below curve where the tangent line is horizontal. That happens at the vertices of these parabolas. These are called local extrema. That is a max point, and this would be a local minimum point, as well with this one. Okay? So, wherever the tangent line is horizontal, that tangent line has a slope of 0. What gives us our slope? The derivative. So we're going to look for the places where the derivative is equal to 0. So I'm going to find the derivative of our original function, this one right here, ends up being 4x cubed minus 12x. That is f prime. To find where the derivative is equal to 0, where it has a horizontal tangent line, I set the derivative equal to 0. And then I'm basically going to be solving a algebra 1 equation. I'm going to factor out 4x. Set each of these equal to 0. This one I get 0. And this I get x squared equals 3. I take the square root. So my answer is going to be plus or minus root 3. So my 3x values that where the derivative is equal to 0 are going to be 0, root 3, and negative root 3. Now it says find the points. A point is comprised of an x value and a y value. So I need to find the y values for these 3x values. So how I do that is I take these and I plug them into the original function. So for 0, plug that into this one right here. So f of 0 is 0 to the 4th minus 6 times 0 squared plus 4, which gives me 4. So my point 0, 4 is where it has a vertex of a parabola, and you can see that is indeed the case. Now for x equals root 3, substitute that in to the original function. Root 3 to the 4th minus 6 times root 3 squared plus 4. I went out beyond a little bit. Root 3 to the 4th is simply going to be 9, because root 3 squared is 3, and then squared again would be 9. So it's going to be 9 minus 6 times 3. Root 3 squared is simply going to be 3 plus 4, and that gives me negative 5. So at root 3, negative 5 is going to be another local extrema. That's going to be right here. And then for the last one, for negative root 3, some of y'all might be able to see this. See this how these are both even. That means that negative is going to disappear. So it's going to end up with the same exact y value as positive root 3. So our 3 points are root 3, negative 5, negative root 3, negative 5, and 0, 4. Okay? And you're going to need to know these, the derivative of sine and cosine. The derivative of sine is cosine. The derivative of cosine is negative sine. Okay. So if I was going to find the derivative of this one, simply going to be 3, derivative of cosine is negative sine of x. So it's just negative 3 sine of x. On this one, f prime is going to be 2 plus 5 cosine of x. And this one I'm going to rewrite it as x to the 3 halves. So f prime is going to be 3 halves x, subtract 1, which is 2 halves, so 1 half, minus negative sine of x. Oops, my bad. Sorry about that. I screwed that one up. I wrote that exponent wrong. My bad. That should have been x to the 2/3. Sorry about that. Root goes on the denominator. So f prime of x is going to be 2/3 x to the negative 1/3 minus negative sine of x. So I'm going to clean that up. So 2 over 3 x to the 1/3 plus sine of x is your derivative. Okay. On this one, write the equation of the tangent line at the given point at x equals 0. So we need to find out what the y value is first. So we simply plug in 0 into the original function. Sine of 0 plus 2. That's a quadrantal. Your sine value is your y value. So you can see that it's 0. So it's 0 plus 2. 2. So my x and my y, x1, y1 is 0 and 2. I need to find my slope, which is going to be given for the derivative of the function. So f prime, this derivative of sine is cosine of x. The 2 disappears. So in order for our equation for a slope in tangent line and slope intercept, point slope, my bad, we simply substitute in our x value into the derivative. So f prime of 0 is cosine of 0, which you can see here, it's the x value, so it's going to be 1. So our equation of our line and point slope is y minus 2 equals 1 times x minus 0. You don't have to clean that up any. That's fine. All right. And the last one, determine the points where the tangent line is horizontal. That's where the derivative is equal to 0. So we take the derivative of cosine of x is negative sine of x. Minus 1 disappears, so we we set our derivative equal to 0. We're looking for all solutions between 0 and 2 pi. So divide by negative 1, so sine of x equals 0. Where does that happen? That is a quadrantal. Our sine value is 0, so that happens here, and it happens here. So our x values, our solutions are 0 and pi, but we want the points, so we need the y value. So we take 0 and plug it into the original one. F of 0 equals cosine of 0 minus 1. Cosine of 0 is 1, so it's 1 minus 1, which is 0. So we have a point 0, 0. And pi plug in pi into the original function. Cosine of pi minus 1. Cosine of pi is over here. It's the x value, so it's negative 1. So you get negative 2. So therefore the point pi negative 2. These are the 2 points where the tangent line is horizontal. Thanks, y'all.